So welcome to our notes on reference triangles. And in our last notes, we learned about sine, cosine, and tangent as ratios of sides with relation to an acute angle theta in a right triangle. Now, if we take what we just learned and we apply it to what we learned before that with central angles on a circle, if I have a terminal side of a central angle here in quadrant 1, and the initial side, remember, is fixed always along the positive x-axis, then this point where the terminal side intersects with the edge of the circle, that has a coordinate x comma y. All right, it's somewhere on the coordinate plane, x units over and y units up. Now, if I form a right triangle using that point, so I'm going to take my line segment and go from that point of intersection with the circle at xy and drop a perpendicular line straight down to the x-axis. Now I've formed a right triangle within my circle. So this, because it was perpendicular, is my right angle, and then the distance from the center of the circle, which is 0, 0, the origin, to the point where that perpendicular intersected with the x-axis, that is x units, since this point of intersection with the circle and the terminal side had x as its first coordinate. Okay, then the vertical distance from the x-axis to that point of intersection, that is the y value of the coordinate. And the hypotenuse of this right triangle, because it goes from the center to the edge of the circle, is the length of the radius of the circle. So we have x, y, and r. And this theta is the central angle, the ray formed by the initial and terminal sides with the vertex at the origin, and that's an acute angle. So I can identify the sine ratio. The sine of theta, remember, is the opposite over the hypotenuse, and the opposite of theta is y, and the hypotenuse of this right triangle is r, the radius of the circle. Okay, then the cosine is the adjacent over the hypotenuse, so that would be x is adjacent to theta and r is the hypotenuse, so the cosine would be x over r. The tangent is opposite over adjacent, and that would be the ratio y over x. Okay, now we have 3 new trig ratios that we're going to talk about today, and these are the reciprocal functions of sine, cosine, and tangent. The reciprocal of sine is called cosecant, and so if sine is y over r, its reciprocal cosecant of theta is r divided by y. Then secant is the reciprocal of cosine. So since cosine of theta is x over r, secant, its reciprocal, is going to be r over x. And similarly, the reciprocal of tangent is cotangent. So if tangent of theta is the ratio y over x, cotangent of theta is x divided by y. Okay, now what's interesting about putting these trig ratios on a central angle in the circle is, remember, that terminal side is not restricted to just the first quadrant where x and y are both positive. We could take that and put it into the second quadrant, right, by reflecting, and now the terminal side has, where it intersects with the circle, a negative x and a positive y. Then in the third quadrant, both x and y would be negative. In the fourth quadrant, x is positive and y is negative. So depending on which quadrant your terminal side lies in, is going to determine whether your sine, cosine, tangent, or their reciprocals are positive or negative. So unlike right triangles in Euclidean geometry, where we just had positive lengths of all of the three sides, now that we're on a unit circle, we can have a negative x value indicating that we're headed to the left of the origin in the x direction. We can also have a negative y value if we're headed down in the y direction from the origin. So that's going to mean we can have negative trig ratios as well. So looking at example 1, we're going to find the sine ratio of the acute angle theta, and the point of intersection with the edge of the circle is given as -3, 4. So when I create my perpendicular line to form a right triangle, I'm going to go to the x-axis, and that forms a reference triangle with my right angle here. Then my central angle, theta, has to be an acute angle. So this is my acute angle theta. The distance from the center to the intersection with that perpendicular is the x distance of the ordered pair, so that's -3. Then the vertical distance is the y value, that's a +4, and that's step number 1, to form a reference triangle with the x-axis. Now step number 2 is to use the Pythagorean theorem to find the length of the radius. We're going to keep that exact, reducing radicals when needed. So if my sides of the right triangle are 4 and -3, then to find the hypotenuse of that triangle, which is the radius, I'm going to need to do the square root of x squared plus y squared, which is 4. So the radius is the square root of -3 quantity squared is 9, and then 4 squared is 16, and 9 plus 16 is 25. And the square root of 25 is 5. So the length of the radius is 5 units. 3, 4, 5 is a Pythagorean triple. And the sine, recall, is the y over the r, right? The opposite over the hypotenuse, which would be 4 over 5. So the sine of theta is 4/5. Okay, then looking at example B, we want to find the cosine of theta, and we're going to drop our perpendicular to the x-axis to form a reference triangle. Then the horizontal distance is the x value, which is -3. The vertical distance is going to be our y value of that ordered pair, -6. And then we need to find the length of the hypotenuse, which would be the radius of the circle that intersects at -3, -6. So r is equal to the square root of the x squared, which is -3 squared, plus the y squared, which is -6 squared. And that's going to make the radius equal to the square root of 45. And we want to always reduce our radicals. 45 is 9 times 5, so the radius is equal to 3 square root of 5. And cosine is defined as adjacent over hypotenuse, and that's going to be x over r in this reference triangle. So our adjacent side x is -3. The radius we just found is 3 square root of 5. And step number 4 is to rationalize the denominator and simplify any fractions. So our 3's are going to cancel here and leave a -1 over root 5, but we need to rationalize that denominator by multiplying the numerator and denominator by the square root of 5. So the cosine of theta reduces to negative square root of 5 divided by 5. Okay, looking at the last one here, the cotangent of theta, when we make our reference triangle by dropping a perpendicular to the x-axis, then our horizontal distance is 2, the vertical distance is -6, and theta is our acute angle. And we're looking for the cotangent of theta. Cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, or y over x. So cotangent is x over y, which means we don't need to know the length of the radius for this one. So we're going to make a ratio of the x coordinate divided by the y coordinate. And we want to reduce that fraction. So cotangent of theta is equal to -1/3.